So, so for Ace, we've like used ChatGPT in the past to just do like interview prep, and currently we like use interview prep at the moment. Sorry, we use ChatGPT for interview prep at the moment, but I'm working right now on replacing it with DeepSeek because it's a lot cheaper, and also just definitely better. So ultimately, what I've started out with. Oh, it's locked. Okay, there we go. Yeah, that's nice and big. Okay. What I've started out with is just like I have a very similar function for ChatGPT, um, or the API for ChatGPT. So what I'm doing here is I'm making a network request to a local instance of DeepSeek that I have running. So I'll just show that. Um, oh, my mouse is not plugged in. Second. So I am just running Ollama serve. So through Nix I have what have I done? So if it's of interest, what I've done here, because I obviously this is quite a part of it, is I have NixOS on my computer. So I'm going to show you guys this because ultimately there's not really a way that you're going to hack me from seeing this information. So why not? Um, I have I have this configuration.nix, which describes my computer and the packages that I have on my computer. I can set up other networking stuff on here, but I use Nix because it makes package management a absolute breeze. What my experience with package management as a whole has been like I started as a Windows user, and there's a lot of like anything has like 17 steps to install something. So you have to make sure some setting is clicked on or whatever. You have to add like a path variable. um, you have to add the right in the right way, and it's also not super clear in any of those cases, and I found I was doing a lot of trial and error. Not for that reason I switched to Linux. What I found over time is that I'll have package management conflicts. So I'll have like, one project requires like, let's say Python request library. One version requires requests version 2, and another requires request version 3. And they do not cross over. There's no middle ground between the two. Like, let's say I'm using a really old package that works well, but still uses an older case, then I'll run into issues on Ubuntu with managing those packages because it will kind of be a teeter totter, and pulling back and forth between which package I have in my environment. And you get into like things like virtual env with Python, um, but this is just a whole lot simpler. This just allows me to work from a package list that is curated. So all of these packages, like if I have like these 17 packages, I know that no matter what, these will work together. They're all using the same versions. Um, it's like a package set, you can think of it. And so I was able to ask for the Ollama package from my unstable packages. So that's just like a very up to date, like kind of like nightly version of Nix packages. And I was just able to get Ollama. So I did that. I did NixOS rebuild switch to put this into effect. And now I have Ollama on my command line. So I can see Ollama here. Typically what you would do is you would just go to the site for Ollama. It's just here. Yeah, you just do download. So on Linux or normal Linux, you would just do this. You can see the other cases for Mac OS and Windows. That's how I've done it. All I need to do now is I need to. How did I get here? Actually, I want to say. Where is I running it? Ollama. Oh, let me just try this. Ollama. Test my memory here. Ollama run DeepSeek R1 1.5b. So I want to run my model, which is DeepSeek R1 1.5b. I think the 1.5b stands for 1.5 billion parameters. And so this is the smallest model, and I'm just kind of using this. I'll be using this today because it, like any larger model, starts to really take a lot of time and a lot of computation. And we're on a video call, so that already takes a lot of computation itself, or RAM more specifically. So I can just say hey, but I'll see this error that I cannot connect to the Ollama app. And so that's why I need to come into this terminal here and do Ollama serve. Be more efficient with my terminals here instead of having another terminal open, because I don't want that. I'm just going to say Ollama serve ampersand. And what this does is this is just going to make it run in the background. And then as you can see, I have access to my terminal again. So now I can say, and this might be annoying for logs. I do want to try this. Ollama run DeepSeek R1 1.5b, and I'm just gonna say, hey, how's it going? Yeah, and this is gonna be a little crazy because that's okay. That's a lot. Never mind. I'm gonna run this in a different terminal. So we see that we have Ollama running on our computer. Quite simple, easy to use. Except I wanted to like go further than this. I wanted to have like a nice interface that I could actually do a lot of work with. So fun fact, I also have another YouTube channel where I talk about like American football. So you know, I'm currently using, I actually just built a video that I'm going to publish today using DeepSeek. DeepSeek is incredible for that. Like I could not do that with ChatGPT before, and it's like now with DeepSeek it's working perfectly. So I was definitely motivated to use what I had already kind of built for ACE to get something going for my YouTube channel, so I could get like a workflow going. So yeah. But and the first thing I realized is like this is going to be like a lot. Like, this is going to be quite cumbersome because in this string I want to be posting in like a full a script and like some context and history, and that's like a little annoying. I can do that manually. There's ways I can do this, of course. I just don't want to. And so what I realized is that, and I'm forgetting what I can also just hit this URL here. So let me copy that. I can just curl this. Oh, don't want to do that. Oh, because I didn't copy it the Emacs way. There we go. And let's see, 404 page not found. What was my... Just trying to remember the command I did. Oh, that's not very helpful. I guess I could look up here. Okay, well, I figured out that there's like ultimately I can use this URL here, and I can do a post request with some data that gets cut off here, and I can just format my request that way. So that's led me to here. So now I am building a client side request to my running DeepSeek model, um, and I can get some information back. So I tested this by saying, what is it? So I have this function ask DeepSeek. I'll just show you guys how it works here. I'm going to do the same thing. Hey, how's it going? And I'll explain all this, of course, in a second, but I just want to show you guys what we're doing. 5B. Ask DeepSeek takes a manager, which we'll learn about in a second, a choice of model as a type, and then a string that will be my question to DeepSeek. And so I now have this back as, what is this? What's the type of X again? Oh yeah, it's an either text or DeepSeek response. So I've modeled in, I think it's actually nice that we're going at a high level here before we are digging into what's going on, because there's also going to be, like, I almost find it easier to build my own stuff than read other people's stuff, because, you know, it's just, if you wrote it, you know it. You know, I know this obviously because I've written it. So, but the thing about Haskell that's really nice is that I don't have to differentiate between my code and someone else's code. I can come in and I can see that X is of the type either text or DeepSeek response, and I know immediately that this is a function that can fail. So if it's a function that can, this is a result that could have failed, is what I should say. Right, ask DeepSeek, if I check the type of it, is something that takes one argument, two arguments, three arguments, and then returns a result which might have failed. So immediately before I even dig into the function, I can see that the thing itself may have failed. And you'll see when you're using IO a lot that there is a lot of use of either, right? So like we have like I think Kyle talked about this in past lessons. Oh yeah, that's fair. Use prelude.readFile. I have another number of modules imported here, but we'll have a function like readFile with file path and IO. But what happens, of course, if I say read file nonsense dot doesn't exist, right? It's going to fail. It's going to give me an exception, and so I could use a function which is safer and allows me to recover from that exception by instead returning an either type, right? So this prelude.readFile kind of assumes that you're going to give it something that is real, whereas if I was to rewrite the function so that it does return an either text or file contents, then I will see, and file contents is just like a synonym for like string. I will know that this can fail if I give it something silly. Anyways, so that I think that's a little overkill, but that's what we're doing here. So, I should show the request first. I have this function that I've written called G, and I'll explain this function and thought response answer, what's going on there in a second. That'll come towards the end, but I can see that, hi, I'm a virtual assistant, so I don't have feelings, but I'm here and ready to help you. How are you doing? And the reason I'm using this G function is because the actual just printout of X is a little bit more terse. There's a lot of information we don't want in there. So my G function ultimately just gets the message and then does some information with that message to make it print out nice and neatly for me. So yeah. So the first thing that I'm doing here is I'm using the HTTP client library. So let me just try if Google running. I do. And so this library, you can also find it through Google, like the normal Google. I am just using this parse request function. So let's go and see what this parse request function does. This is pretty awesome. Makes it really easy to get started with the library. And there's also like a simpler, HTTP simple, I think it is, or HTTP client simple, that helps you with the types of this library if they get confusing. But I found this library to be a bit better or more approachable for myself. So what this does is this takes a string and returns it as a request. So this is like an unsafe, this is like a string which isn't very well typed. It can be kind of, a string can represent anything, and so I want to now convert it into this like clear type that has my method. Is it secure? Who's the host? I'll see that the host is localhost, and so on and so forth. So everything you would expect to see in a URL. It will give us direct, clear information and typed information about if it's there or not. And yeah, and also too, like this kind of creates like a bit of a default request. Like there's not a ton about it. Like we haven't given it any request body yet. But yeah, and then you'll also notice this monad throw here. One possible case of this is either. Another possible case is maybe. Another possible case is IO. And what this is saying is that the M has a property which allows us to fail. So, we can choose ultimately through our types how this should fail. And so here I've chosen that it will fail. Oh, this is interesting. Oh, I guess that makes sense. This must be using IO as the monad. I am using like monad IO. Monad IO is ultimately, it's another type class specifying a property about M. And ultimately all it's saying is that, this monad can do IO stuff, and this monad can do throwing error, right? So this, what is this? Yeah, throw M, throw an exception. And so one of those cases we'll see is IO here, right? And as I was saying, maybe is also a case. Either is also a case. And yeah. So we start off with a request here, and now I want to add some more information to it. So we can jump to here, and we'll see that I want to change certain fields of it. And so this is kind of like a record syntax you can use. So if I look at request, I'll see that I have request headers, and I can use that label to pick a new value for it. And this will just override whatever value is in there. If you don't like using lenses, or you've come across lenses, this is a much easier way to avoid lenses, I'll say. If you haven't heard of lenses, that's okay. You don't need to know what lenses are. I'm trying to push you guys away from them, because there's something that's cool, but like not. I don't think it's personally worth the time to learn. In my opinion, I just don't use them. Anyways, same with method. I'm going to say that method is a byte string, and I'm going to say method is post. It's kind of interesting to me that that's not typed, but I guess we could in theory say method post. I've chosen a response timeout of none because for using larger models, this does take a lot of time. And then here's the actual interesting part. As with any post request, um, in case you guys are not familiar with post requests, you are giving the arguments or the data or the payload, whatever you want to call it, in the body portion of the HTTP request. A GET request would look more like this, where we have param1 equals value 1, and we can chain them using this ampersand. So I have param2 equals value 2, but here we are just using a post request. So in our post request, like I said, we are just putting it in the body, and I want to make sure that the body is the JSON matching the API specification. So I started here. Oh, sorry, that's a different one. I started here and I was looking at the DeepSeek API docs. I kind of assumed that they would be the same for Ollama, but Ollama actually has a different specification. So I'll show you guys an example here. So like a very simple case, we can put the model and we can put the messages, and the messages is like a list of this particular object. If we can kind of think of this as types too. We can use Haskell and lean on our types, because ultimately what you'll notice is that it's not super flexible. Like sure, in like this case we can have images, but in every single case we're gonna have role and content, role and content, right? Role, content, and so we can start to like use Haskell types to model what this is, and then we can lean on the ASON for JSON objects library in Haskell to make this nice and intuitive, and well, very very simply easy to use. So I'm going to go to types. I'm going to look for DeepSeek. So that's exactly what I have here. You can see the commented out fields. This is literally a work in progress. I was working on it last night, and I said I'm going to take a break. And I actually didn't plan on doing this today, but with all the G's question, I'm like, okay, this is perfect. I'll just do it anyways. I can see that you can see that I've sort of typified DeepSeek request body, and so if we go back to the code as well, util's, oh, right. You can see that I'm doing this ason.encode prompt. So this prompt, as we'll see, is of the type DeepSeek request body. And I just have this function make ds prompt, which is going to build this for me, and I'll explain that in a second. But I can use this to create an ASON encoded prompt, and the default way to do this is that I have my type. I can think in the Haskell types and then and not worry about how they serialize the JSON, because that's handled very logically for me. And then I just have my instances of show, and I'll need my generic type class for DeepSeek request body, and I can this is how easy it is. I can literally just say instance to JSON DeepSeek request body. And that's all I have to do. And so now this will automatically deserialize for me. And that's straightforward and easy. You might be wondering, like, why do I have like these names for the type DeepSeek request model. That's because I also if I look at my DeepSeek response, it also has a model field, and so I've kind of prefixed it. I saw this pattern before, and I really like it. I prefixed it with this DeepSeek request, and then I have a more generic way of creating my my to JSON instance, which is just this function called this function derived JSON, which uses template Haskell, an advanced feature of Haskell, to to build it for me. So what this is saying is take my type of DeepSeek response and just remove this prefix, right? Scrub this prefix. So for example here, oh, is this like right below? I'm doing it for both DeepSeek request and DeepSeek response. So let's look at like DeepSeek response as an example. This is literally just going to take this piece off, and I'll see in my JSON that the field is model. So yeah, and you might be wondering about like images or whatever. And I want to explain this part because I want to take any chance we can to learn about Haskell data types and how to think in them, because that's like the most important thing you can take away from our course. Is, let's say we want to add in images here, add it in a way to pass images. What is the field name? Did I? Images. Images is optional. So I can model that by just saying maybe t.text. I don't know what's a more appropriate type for images. I'd have to look more into the API, but I'm just going to say DeepSeek request images is of the type maybe text. So that means when this encodes the JSON, JSON will automatically handle that maybe case in an appropriate way. And that just simply means that the field itself may or may not be there. So where am I? I'm also going to need to add to my default case, or my default instance, because I've added to that. And this default just kind of creates like a base DeepSeek request body to work with, because I don't want to, if I have like 17,000 fields here, I don't want to be forced to type them in each time. So I can just create a DeepSeek model with a number of, individual defaults, which will ultimately do nothing unless I change them. So DeepSeek images. I'm just going to say the default is nothing. Let's check that type checks. Right, I still need to get rid of this. Cool. Fun fact here. I feel like I'm going on a lot of tangents today, so I'll cut it out. But fun fact here. I'm excited about this because you'll see zero warnings from our Haskell repository. There was one point where we had 1,600, and I got rid of them all. I took a week and I just blitzed it. I think it was actually 2 weeks, but I just blitzed it. And thank you. I don't know who gave that response, but and now we have zero warnings, and like it's cool because like and I've also stopped. I've disallowed any warnings in our repository at this point, because for Haskell, a lot of the warnings are actually like really useful. I find like in JavaScript or whatever, it's like, oh, I don't like how you name that, and I'm like, I don't care about that. Like get out of here. Whereas in Haskell, it's like you should consider this case, or like you've written this in a way that's like not perfect. And maybe we'll see that. I'll leave that to an actual example as it comes up. But yeah, so that's what we're doing here, right? So we ultimately, as a review, we have created this type that models a request body, the payload that this API is expecting, right? So just like this, yeah, just like this, and then we have created a default just so I can quickly build it, right? I could just say, here I could literally just say default, for instance, and this will pick the, whatever the value of this is, just to show that in context. But I'm going to build a specific one, and then I'm going to, and then I'm going to encode it to JSON. So yeah, and I haven't explained the headers. Let me know if you get confused there, but I'll continue on without it because I think that's pretty self-explanatory. I also encourage like just looking into HTTP as a whole, because that will help you with coding in general. And so how are we making this prompt? So I have this function make ds prompt. Where is it? Oh, it must be in types. There we are. And so I'm just using this default instance. So just, the value of this at this moment, before I add any of this code here, is just going to be whatever we saw before. And then I'm just going to simply override the model that I want to use and the content with role. So this is actually really kind of funny because I built this type for ChatGPT, but I was able to just simply reuse it. Where is it? Yeah, content with role. So it's called GPT role at the moment. I want to change that so it's actually not that. But I'll work on that later. And this will just annotate like who said what. So did the system say this, or did I say this? Is ultimately how we're going to be using it for Ollama. And so I can add a bunch of those in. So how am I actually using that? Well, I have this make ds prompt usage here, where I'm taking the model ds from Ask DeepSeek. So in the example, we saw that we're using the 1.5b model from DeepSeek, and the content. I have this little helper function, content with role. This is ultimately the same thing as like if I just had the type constructor. Like literally, if I could plug and play that. It's just literally shorthand. And then because we're saying it, I'm just pasting in the contents here, and that builds it out. So that leads us to having a fully formed HTTP request. So how do we go about this? Well, we're gonna use this is a bit looking a bit contrived here, but we could, for example, say HTTP LBS of our rec, our updated request, in the manager, and this will give us back a response. So let's go. I'll just go to the docs for this one. And by the way, I'm in the package, so I'm just hitting S so I can search through the package. And I see HTTP LBS. Okay, there we go. So a continuous wrapper around with response, which reads the entire response body and immediately closes the connection. So this is kind of like the simplest way to go. I think they even have like an example somewhere of how to use it. But this just returns the response as a byte string, right? So response is a higher kind of type that allows us, in theory, to, you know, change out what the, like how we deal with the response, or like what the actual type of the response is. It's always going to be the same content, right? It's always going to be like if Ollama said, "Hey, how are you doing today?" It's always going to be, "Hey, how are you doing today?" as the like real value. But here, what HTTP client library does, um, and I believe this is for streaming purposes, is it allows you to get this as a response body reader. So if I wanted to stream this, what you can do, like if you wanted to build something very similar to DeepSeek, where you're like, and this is probably not going to respond to me because, it hates me. Um, but if we wanted to do something very similar to that, right, where we're going to see, word by word coming through, we'd want to do streaming. And so just simply higher kind types allow us to simply and ergonomically do that. But anyways, that's a story for a later date. We're just going to get the response as a byte string. So the only thing we've looked at what a request is. A manager is just simply something to help manage the connection. And so this is like pretty straightforward to use. I won't go into that too much. I just create a manager by, I'll show you guys in the command line. I create a manager by saying new manager TLS manager settings. And you'll see that new manager is just taking a settings object and returning a manager settings. Right. So how do you want this to be configured? Okay, I'm going to build it for you and give you back the manager that you can use for subsequent HTTP requests. And so now that I built it, I only need to build it once. And TLS is just like, in case you're not familiar with it, HTTP is not TLS, whereas the HTTPS is using TLS, which I believe stands for like transport layer security. It's been a while, but ultimately you want this to have secure connections. So that's why I've chosen it. I don't think I actually need it for localhost, come to think of it. Yeah. Actually, I'm curious what's something. Does manager have a default?
You don't need it for localhost, but
No, I definitely don't. No,
I think you actually have to set up certificates if you're using localhost.
Yeah. Okay, well, I'm just going to do it this way anyways, just to show a more generic thing that also works here. We don't need HTTPS, but it is going to still work. So, so that's that, and that will allow us to get back something from our API. And so, what am I doing here now? This is a little bit contrived. I'll rewrite this without using this. This is just more. Okay, so here's my response, and then I'm going to say case response of, yeah. This is just the same code as before. I was using like a bit of an advanced feature. It's just like an advanced feature to like change a little bit about how I write it. It's a little bit more ergonomic to use. Less lines, I guess. But anyways, response. What is the type of response? Let's just do this. And response is either an HTTP exception or an LBS byte string. LBS is just because at the beginning I did import data dot byte string dot lazy as LBS. And so LBS just simply refers to the byte string type from the data.bytestring.lazy module. And that's because I have a number of different modules for dealing with very similar types. So yeah, so ultimately either the request failed for some reason or we got back a byte string. Now, if we think about this too, there's also the case that we're going to have multiple failures. I'm going to just put this in here, HTTP exception, and lbs.bytestring. Just going to annotate that, just so we see what we're dealing with here. And if we want to pattern match on this response to see what happened with it and then handle that accordingly, we use this case statement, and we deal with the case that it was the left case that it failed, and we're just going to simply show that error. So I have this function which is also a little bit contrived, and it just means the same thing as that. I'm going to use the show instance of HTTP exception. Pardon me, which is just to return it to string. For some reason, I decided that I want to return this as text. So just staying true to that type, I have to use t.pack to turn from a string to a text, and then just wrap it in left to show that this failed to whoever reads the result of this. Right, because I know that this failed, but whoever used this function, do they know that it failed? Or the successive functions, how do they deal with the error as a result of this? And that could be many things, right? Like especially like if this was like a user facing case, like like maybe you guys have seen with like ChatGPT, where like it'll say like sorry, like the server is busy right now, or something like that. We want to be able to explicitly handle that case instead of just returning something random, right? Literally something random, or nothing at all, or whatever. So in addition to the actual request failing, we can also have an unexpected response from the body, right? So I saw this error. I was getting the left case a lot because at the beginning, because I didn't know what the type should be. And so if I look at DeepSeek response, I had to like change this up quite a bit. So for instance, I was getting like all of these maybe fields were not always present, and I actually don't even know if all of these maybe fields are even ever there, because I was originally focusing on the DeepSeek docs. Yeah, I'm gonna try to remove them for now. I should, and that should work. Yes, I just need to get rid of the type wildcard. Binding for response, shadows existing binding. That's an error saying that I'm already using the response type somewhere. I don't know where I am, but I am definitely using that. Like I'm using that name already somewhere in my code, so I should differentiate that by picking a new name. I've kind of come up with this little like naming convention of like the underscore at the end to say like this is just simply a value, is what it means to me. Yeah, so I just removed those fields, and maybe they do exist or whatever, but we'll look at that maybe at a later point in this lesson. And so, anyways, this is just going to do the opposite of what we were doing before, right? So we were doing to JSON, and I want from JSON. So this derived JSON, by the way, does both for us, right? So this is equivalent to doing instance to and from JSON. I can even like I've done for like the DeepSeek model. I can do like a full-on instance of from JSON if I want to make it custom. I don't even like it, right? I don't even need this. This is the bare minimum I need. Here, I just wanted to like I just wanted to like specify how to go to and from because it is a bit different. And then here I'm just using some advanced template Haskell to quickly build out my to and from JSON of DeepSeek response. So this either decode is coming from JSON, and if we look at the type of either decode, can I also oh, okay, that's nice. Yeah, type of ASON dot either decode. I can see that this takes a byte string, right, which we have in our request, ultimately, right, somewhere, yes. This takes a, yeah, we have, so that's what we have in our request is this byte string, and it will return us either a failure, an error, or something called A, which has a from JSON instance. So because I have used, this code here to create the from JSON, this should work. Sorry, let me just go back to that. So let me test this finally. I guess, yeah, like, so if this succeeds, then that means that this function as a whole has succeeded. And so that's ultimately what it is. Right, so we have two failure cases. We either failed because the request itself failed, or we failed to parse it through JSON. And we have now made this very robust function, which if it fails, it will deal with it properly. And if it succeeds, it will deal with it properly. So let's go back here. So now actually using the function again, I'm just going to say, hey, how's it going? Oh, right. Manager. This should be relatively quick. I'm not streaming it. I've told it not to stream by default. That's the response. And so we can see that it's of the type write. It's a DeepSeek response inside of that write case. And I can see what model I used when the response was created, and ultimately the message. So I'm gonna do something else here, which is just I'm gonna say lift.io print res body. I just want to show you guys like what this looks like. So this is the like raw response body, and It ends up escaping a strings or whatever. So I guess it's not fully raw, but ultimately is quite raw. So I can see here that my content, I have this like think, hello, I'm a virtual assistant, so I'm don't have feelings, but I'm here and ready to help you. How are you doing? Is everything here, right? So I can um, paste that, and that's what ultimately what we have here. And so I can deal with more complex JSON types by also having this content with role here, which itself has a derived JSON, right? So same thing. I'm just getting rid of the prefix and pardon me, um, and turning that into JSON and yeah, and mapping back and forth from JSON to the actual Haskell type. So the content with role, like we see before, oh, is just the role. So this will be, I believe this should even say role assistant. Yeah, assistant. So we know that this is from DeepSeek itself, or Ollama DeepSeek, and the content, which is that. Um, any questions so far? Does anyone want me to go over anything further, or should we continue moving on? Um, if you do have any questions, please absolutely ask them. There's a lot that we covered here, so is that something in the chat? Oh, okay. Um, so next we'll look at so like I want to do stuff with this, right? So the first thing I noticed is that if I run like DeepSeek here, it has this think. Oh, right, I'm in the annoying one. You know, better question is, what is 9 plus 10? Fun fact, I asked DeepSeek, I just gave it a list of E's. I gave it like 30 E's, and it had like an existential crisis. It was pretty funny to watch. Let me actually try that again for fun.
The user's sending me a list of E's. I wonder, like the deep think is hilarious when
So
it's
good.
yeah.
My fiance sent me a meme of it was like the person asked like just said like, hey, how's it going or whatever, and DeepSeek like has this whole like deep think, and it's like, oh, like the user responded like like asked me a question, said hello in a very casual tone. I should think about how to respond in also a very casual tone. Blah 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 blah. A lot more deep thinking to it, and then like it just responds like the actual answer being like, hey, how's it going? How can I help you today? Or something like that.
Yeah.
And the meme caption was when your crush texts you. So I thought that was pretty funny. Um,
That's funny.
yeah.
Just
Okay.
like overthinking everything.
Yeah. I almost want to see if I can like teach DeepSeek to be stupid. Like just like don't overthink this. Like bro, like you're overthinking, man. Like you know, like I think you gotta chill, bro. Like do some meditation. Nothing against actually meditation's very smart to do, but um, I did run this with the I at one point was running. I definitely can't do it now, but I was running the 32B on this computer. The RAM on this computer is very heavily upgraded because we do a lot of build stuff on this computer uh, for Ace. But it was like it was hilarious because it was like it was I wish I had it. It was like talking about like maybe this is a cipher, maybe this is like a song, maybe this is like maybe I should convert it to the ASCII values to see if there's like a message hidden in this. I just kept trying and trying, and everything made no sense to it, and which is so cool. I want to learn. I haven't read the research paper yet, but like, I imagine there's like, to my understanding, there's you know, a sort of threshold of like this makes sense that it has to hit. And if if it doesn't reach that, then it continues trying. So, um, yeah. So
Yeah, it does
that
all its thinking before it actually replies, whereas ChatGPT just replies with the very first thing it thinks.
it hallucinates.
Yeah.
Um, what's so cool too, I think, is like I don't know if it'll work with the crappier model, but this like common problem. Maybe if I run it with 7, this will take a second. Um, but ChatGPT classically bad for counting the number of letters, and this is really cool. I don't know if it'll do it here, but it like just lists out like it like I guess it knows how to enumerate through letters and numbers, and so we'll just put like side by side like 1 S 2 T, and this will fail. I think this might fail because it might say that R is repeated multiple times. Oh no, this is yeah, okay, that well, yeah. See, it got it right, and now it's like overthinking it. It's like, mm, yes, the better models this won't happen. Um, but yeah. Um, where am I? Okay, so now I want to do stuff with this DeepSeek response, and so I have this function, um, to thought response. So I just wanted to like annotate like what is the difference between like or like can I get the pieces as like their individual pieces. Like I want to see like the thinking, and then I want to see the answer, and I want them to be easy to use. So instead of like having to like do some crazy introspection and parsing every single time, I'm just gonna use this thing called to thought response, and it will build me this thought response with the. Sorry, Kyle, you're unmuted, and the
Oh,
typing is very
my
loud.
bad.
Your keyboard is so loud. I feel so bad asking,
I
but
know.
it's a cool keyboard by the way. But got like one of the like uh you know I don't know what they're
Split in
called.
two.
Split
It's
in
a
two.
split. It's a split keyboard. Yeah.
Yes. Um. Anyways, so I did this, and we can see the result of this. Do I? Yeah. Okay. So can I just say to thought response? Okay, there we go. So I've to thought response. I'm gonna say join. Join just I see that I have multiple ithers, so this is just gonna combine the result into one. Um, this from control.monad. Right. Oh, I can't combine it because they're different failure cases. So I'm gonna be quite lazy here. First I'm gonna set prompt to something less cumbersome. I don't care what modules I have in here. Um, I'm going to say from right undefined. This is I would never do this in production. This is just like I want to quickly get the value of this. What is the what? What's the type of X? Right. Okay. Um, I need to say in here to thought response. So first, I'm going to apply from right undefined. I'll just do this here. The type of from right is simply taking a default value and then collapsing in either to the um, to the result. So like to the successful result. So either no pun intended, this succeeded, or we take the default case. And so in this case, I'm saying undefined is the default. That's because I'm in the terminal and I know that I know that it succeeded. I would never use this in production. So I actually just implemented a much more verbose like error handling system, which I'm pretty proud of. It took like over a year, but it's finally there. So like in any case, for any issues with Ace, I should see them immediately. And it also gives feedback on like user errors, so we can like help improve with like the UI. But that's a story for a later date. Anyways, I am definitely off track there. We have this to thought response here, and now let's actually make this like legible to read. I'm just gonna say, give me the thought response answer field. So I don't care what its thinking was. I'm just going to do answer, and I see that I have it as separated lines. So I can just do, I guess the best way to go here, I'm going to call print on each of these cases. And so like map M, by the way, takes a function which does some side effect and a more often than not a list of things. Like so here we like you'll see that a foldable is like a you can think of it as, in this context, as being a property that a list has. So a list is foldable. A list has a foldable property to it, right? There's a way we can fold, whatever that means, a list. And if you don't care for what that is, then we could just think of the T as being the list type. So that would mean that our revised type signature here, which is fully valid, right? We haven't oversimplified anything. It's just one case of foldable, is this list here. And I want to reduce this other monad constraint here. So I'm just going to pick the IO monad, and that will be IO here. It's going to say, what the heck are you doing here? Because what am I typing in here? I'm not actually defining map M. I'm just writing some pseudocode. And yeah, so that's fully valid. And that's exactly what we are doing in our case, right? We are actually working with IO, and we're actually working with a list. So I'm just going to print out each line of this. But also I know that I'm working with a string. So I'm gonna do this so that I don't have like I don't want to see this. This is ugly to me. So instead, I'm just going to use put string line, which would take a string and print it without doing this, right? In this case, it would just show nothing. I want to use the t.put string line because technically this is text that I'm working with. I just decided to use text in this case. Text and string are ultimately the exact same thing, but one is just more efficient implementation. And so I can see that it gave me that. Cool. Could even ask. Let's ask here, what is 9 plus 10? This might take a second. Cool. That's the raw response. And now I'm just going to call the same thing. And I just print this out as I would see it in the terminal anyways. So, yeah, that's I guess that's I guess I'm trying to show like what the point of thought response is here. And I started going off with this, um, and I realized like there's other things I can do too here. Like you'll see this code block here, but and I'll show you guys how to use that. But in order to make to thought response, I'm using my library Scrappy. So Scrappy is a library I've created for web scraping. And what I noticed is that this think is like is literally just a HTML tag or XML tag, I suppose. And so Scrappy, although it wasn't built for it, works perfectly with it. And I can write a parser which is going to work with whatever this text is here, and then create it into some type that I can work with much more easily than raw strings, right? Because again, strings suck. They can be anything. They really don't tell us much. This string is not the same string as this string, right? These are not the same thing even slightly. And so we want to avoid strings at all costs. We want to get away from strings as fast as we possibly can, because we have types, and types are easier. Types are certain, right? We want programs that are never going to fail, never going to break unexpectedly. And so the way we do that, the way we ensure that, is through types, and that's regardless of whatever language you're using. You want to use types, and so like, you know, we've done some parsing in the past, not super in depth, but I'll explain what we're doing here, because it's actually like quite intuitive, I think. So we kind of start from our top level here, which is and the module, by the way, I have at the top of my code here text.parsec as PSC. So anything PSC dot is coming from the text.parsec module, such as the parse function. And so let's go look that up quick. And parse, parse is going to take a parser that will define just like an arbitrary name for whatever we're typing here, such as test, and then this string which we are going to parse, and it will return us either a successful parse or an error, a specific type of error. And where am I? Yeah. So here I've not given it any name. Maybe I'll call it DeepSeek parse, DeepSeek response, just some arbitrary name. And X is going to be the source content. I'll just call this here. And so content source is just coming from my usage of types. So we know what DeepSeek response message is, but in case you forget, we have that the DeepSeek response message type is going to be parsed into a content with role, and so by calling this field function, this is going to give us back a content with role type, which we can then call CWR content to just get this as a raw string. This should be, what is this? I believe this should be string. Oh, it's actually a text. Same thing. And we can, since it's text, we can parse with it. The cool thing about parsec is that it works with the way that the types are defined. This will work with anything that is like text or string like. So we could like the value here could be any of text or string or byte string, as long as the entire thing is all the same type. Yeah. So anyways, the first thing that we're going to see in the thought response when we break it down, let's look at this as an example, is we're going to have our think element, and we're just going to parse that out using the parser I built through Scrappy. And we'll just, this is a function which takes the element tag as well as some attributes. In this case, we have 0 attributes. And so this will make us a parser that looks for exactly this. And whatever, it doesn't care. The key thing, the reason I'm using the L function from Scrappy is because the L function is written in a way that it doesn't care what's inside of it. It just knows how to go from one tag to the next. And that will return us this value, which we've named t. I'm going to call this something better here. Think tag. And then we'll just parse the rest of this by grabbing the entire thing, right? So we want to grab everything from here to here. We have no restriction on what is a valid value there. And we're just going to say, so in order to say take the rest, we're just going to say take many of any character. So any character, I think, is pretty self-explanatory. It's a well-named function, I should say. You know, I should stop saying self-explanatory because everything has some nuances to it, or can feel like it has some nuances to it. And so this will take any single character. So if I use this on itself, it would just parse one character, no matter what it is. Many is a function which takes another parser and transforms it, you can think of it, into a new parser, where it will take many successions of that same case. So it will take anywhere from 0 to infinity of the parser that it was given. So it will take 0 to infinity of any character. And that will just be named as the rest. And then I'm just using simply, I'm turning it into interesting. I wonder if I need to do that. Come to think of it, but I'm not sure if I need this pack anymore. But I'll leave it here for now because it's not really important. But then I'm just simply using lines, which is going to break on any new line character. And that's why I have a list of text instead of just, you know, text on its own, right? And that's a thought response. So now, right? So and as we saw, I can literally just say, oh, do I have to go back and do all this? You know, that's why I can simply, once I get the result back, just do something like this, where I you know, work with the thought response answer. So the other thing I wanted to do is I wanted to test the ability to get JSON back definitively, like because that's a key thing that we do for how we model the how we model stuff with our interview prep is we had to make sure that we're getting things back in a very particular format, and so we use sort of a communication or like a common protocol through ChatGPT to make sure that we were getting back exactly what we want. And if we don't get it, then we just try again. And so I was kind of testing this out, and what I noticed is that what's the answer? If I let's go here, let's just do it in this one. Give me only a JSON response with a JSON object of names, of 3 names as keys, and a sentence describing each person. This is the 7B, so it should work pretty well. Okay. I think I need to have an answer. I'm farting, Jason. Pardon me. Oh. Okay, here we go. Finally. So I'm not 100% certain this is going to return valid JSON because of the model. Okay, yeah, that worked perfectly actually. I noticed this case here where it's using mark. So like the response that you'll get from like ChatGPT, as well as a lot of these other like large language models, is like typically in Markdown, and so I believe that's why they have this as a think tag. I'm not totally sure. That's just a guess, but they're using Markdown here, and so I was like, oh, like how cool would it be if I could properly parse this? That'd be super cool. And so I used Scrappy for this. I used Scrappy to run this because, and the reason I use Scrappy, where Scrappy comes in here, is like, let's say like DeepSeek also said right in this like white highlighted part here, here's your JSON response. That's like annoying. That will mess up my parsers, and I will be frustrated with that. Because again, our code has to be very specific and work properly. So I just want to make sure that all I care about is this, and so that's where Scrappy comes in. I have this function which just like kind of automatically ignores whatever I'm not looking for. But the first piece I need to do is I need to figure out how to parse this. And so I think it's worth going into the parsec stuff here, because like parsec is probably the most important library that you'll come across in Haskell, or really any parsing library, right? Like parsing is probably the most important thing in Haskell, because it allows Haskell to be what it is, right? We have the outside world, which is just strings and numbers and very basic data types, right? The outside world is like probably JSON. What I mean by the outside world is like anything like we're gonna get from a server, or any sort of other host or like computer host is probably going to be JSON or something like that. And the key point there is that it's always using like basic data types. Like it's using, you know, like I think it's actually technically floats. Um, it's using strings. It's using arrays and the objects itself and nested objects. And so that's like the full set of like what JSON is. And so we want to be able to take something like that and turn it into some type that we know to be correct. Sorry, I have an alarm that keeps going off. I gotta change that to a different, better time. And so that's why parsing is absolutely incredibly important. And you may not have realized it before, but when we were working with this idea of from JSON, that's a parser, right? We're using parsers there, and they made our lives a billion times easier. That probably would have taken up like an hour on its own to figure out how to parse that JSON properly and to make sure that we're being consistent with it, etc. To do a good job of teaching that lesson would take probably an hour. But I was able to just say, do this. Anyways, so what is the structure of this here? We want to, the first we have to start from the beginning, right? We and go character by character. And so the first thing we see is that we have three little backticks. And so the way that I can write that in parsec is using this count function, which will say how many of the case am I looking for, and the character function, right? So car is kind of like this parsec dot car is like the simplest function from parsec that you can come across and get familiar with. And this is just going to simply parse. So like if I was to say like parse car A on this string of A, it's going to find it validly and correctly. But what about if I said like BA? It's going to say I wasn't expecting that. You told me that there would only be a character A. And this will even work if we have a B at the end, because we haven't told it to do really anything beyond that character here. And so we could also say parse the character B, right? So parse character A and then parse character B. Yeah. And this ultimately, I should probably explain that quickly. This just allows us to run two actions and then toss out the result of the first. So you'll see here that we have just like the right B, and we have no idea like what the result of A was, or what the result of the first piece here was. And so like there's other ways we could combine this. Like we could say like, for example, this is getting a little bit complex here, but I think in the right appropriate way is if we want the value of both, one easy way to do this is to use these combinators to get both results. So I encourage you guys to like read about monads, functors, applicatives, and monads, and the theory behind them. But ultimately, like keep this in mind, keep this in your back pocket as like a key case to like pull down from the high level theory. Anyways, I definitely went on a tangent there, but hopefully it was a helpful tangent. So, okay, so cool. We figured out like how to parse the first three backticks. Now I want to figure out how to parse this JSON piece here. And I also I know from looking at I've done a lot of work with Markdown, um, because part of ACE is like all the lessons are currently built through Markdown, um, and I know that this is optional here. So it creates a tricky case because I'm like, okay, well, I don't know how long. If it's optional, I don't even know if it's going to be there. Um, it could be like any number of strings. So, like for example, I could say, like the worst thing I could try is look for JSON, and then if that like and I'm trying to make a generic code block here. Pardon me. Um, what if it's like Haskell here instead? Then that's going to fail. Okay, looking at the two cases of Haskell and JSON, what if I look for like the longer case? What if I say like Haskell is a 7-letter word? Let me count the next 7 characters, and we'll see if that works. Well, that's not going to work. It's going to cause some issues because you're going to, in this case, in any other case that's not 7 letters, that's less than 7 letters, you're going to say that the value here is like something like JSON new line character angle bracket, put that as 1, 5s, and then I guess like this here. So that would be obviously invalid, correct, and nonsense. So not helpful to us. So I have this function from Scrappy, which is I'm kind of realizing more and more is the workhorse of Scrappy. Is this function many till? And I believe that Scrappy or sorry, yeah, it's weird because this used to have a many till, and then it got rid of it, which I don't understand. But it would return the it would return both the the result of the first parser and the result of the second parser. And so what the idea of many till is that and they actually show pardon me, a great example here. Like let's say you have something that's like variable length, like what we're parsing here is a simple HTML comment. There's not like a restriction or any clear rule on what you can put inside an HTML comment. Like it can be like infinitely long, right? It could be empty, it could be like 0, it could be infinitely long. And so there's nothing we can really think about with that. And so what we have instead is we do know how it ends, how it terminates. And so many till is an awesome function for that, because we can just say take whatever the heck until we reach the end of the comment. So that's exactly what we do here. And we actually use this quite a few times. I realized that before it gets to the next line, it's going to have a new line character. And so it's not showing us here, but implicitly, like if we were to look at an example output here, content, you can see a new line character, right? So this is just like raw text. And that is a valid way of getting the name of this code block, or the code type of this code block, I should say. And so we do that. This here is the new line character. But we don't care about it, so I'm just gonna pattern match on it by using the underscore, which ultimately just tosses it out. And then I'm gonna use many till yet again to say, give me any character until I count the last 3 backticks. And so that makes sense because we're just gonna have, and again, any character. We don't know what the code block exactly is, and we're going to return that. And I'm kind of lazy at the moment. I haven't really created a new type yet for this. So one thing I did is I brought it back as a tuple. And so let me use this here. Is X still in scope? There we go. Answer. Let's call it. What do we even have an answer that helps us? Okay, let's ask what is 9 plus 10? Or sorry, what is give me only a JSON each person. So same thing we asked in the terminal. You also might be wondering like what value would this have for like me as a for the other YouTube channel. I'm currently trying to figure out a clean way to communicate, such as JSON, through DeepSeek, so that I can create a pipeline of scripts for that channel. So DeepSeek, I found out DeepSeek is like amazing at stats. So it's really like it's far better than I could ever do with writing a football script. So I'm like, okay, I got to use DeepSeek for this for sure. So like, the only challenge that I found with it is that like I want a script to be like, let's say 12 minutes or whatever, but it's just too long a response for DeepSeek to make sense of. And so it'll tell me like this next section is 300 words. It will actually be like 100 words. And so what I found I can do manually is that I'll just take the 100 words and say, expand on this, expand on this, expand on this. And so I want just like, I have like 50 ideas for like videos already. And I want to just build a pipeline that can just pump out like 50 scripts. So, yeah. And so obviously in order to do that, I need a system that is well oiled and works well. Yeah. Okay, so X. I'm just going to be lazy and say from right X undefined. We'll call this Y here. The type of Y is DeepSeek response. I want to turn it to a thought response. To thought response Y, I'm going to call this Z. So type of Z is now either thought response or parser. From right undefined Z. Let's call this A. So as I enumerate through the alphabet, and I've reached the end. I can now use, I forget where I did this, but I can now say that I want the thought response answer of A. Perfect. And I want to put them back into one single text. So I have a couple options here. I can say t.unlines, which is just the opposite of what I originally did, lines. Or I could also actually say mconcat here. And mconcat is just like a, getting in more into theory here, is a monoid, which is the idea that like you can combine. Kyle has a much better description of this in his new lessons here, but I think it's chapter 7. But
For which one?
For how to describe monoids, like chaining stuff
Chapter
together.
5, I think.
Chapter
But yeah,
5.
it's the one titled combining functions.
Yeah. So this is a case of a combining function, and we're just like, like it's like I think in JavaScript it's like plus plus. We could even say fold plus plus. I think works. Let's get into more theory, and I'm not even doing it right, but yeah. So this just like combines all the strings into one, right? So like it's like how in JavaScript we could say like, hey user, and we want to continually like tack it along together instead of having like this like kind of more verbose like long expression. We could just say mconcat user, how are you doing? I'll just say user Galen. That's me. And I screwed this up. Hey Galen, how are you doing? So that's all we're doing here. And we're just putting it back into one long thing. So I'm gonna say source equals that, and I have this function in Scrappy called scrape. Let me see if scrape is available. So it takes a scraper t, which to be honest is just the same thing as parsec t. I just like have kind of hidden some types and chosen some defaults, and then it takes some HTML and returns a list of that. The HTML is also just text. We can inspect this if we don't know what HTML is by just using the. I wonder if this works. Yeah, we can ask what that is, and we just see that it's a string. So we can run some parser on some text, and we don't have to worry about what is surrounding that pattern that we want to look for. So for example, very easy example is I could say, give me all of the times P exists here. Scrape car P on source. Oh yeah, and I need to convert this. Scrappy also forces me to use string just because t.unpack, sorry. But I currently have a text, so I just want to convert from text to string, so that works with Scrappy. And then I do that. And I guess I found. Just want to see how many P's there were. and there was 10 P's in there. I'm not going to count, but feel free to pause the video and check if that's correct, I guess. Yeah. And so that's all we're doing here. And now instead I want to look for a code block. So why does this make sense? Why am I about to do what I'm doing here? If we look at the type of, let's say, car P, we'll see that it's a parsec T action, which results in a character. And if I look at the type of code block, I'll see that it's also parsec T, resulting in something else. And so, like, all Scrape cares about is that whenever we give it, and if we, again, I'll just show this here. All Scrape cares about is that we are using like that. This is a parsec action, so it can run any parsec action which results in whatever and returns it as that type. So now that means that I can say well, that's awkward. It worked last night. I don't know why it's not. Oh, you know why? Actually, I don't know why. Oh, because I've removed the new line characters. That's okay. So if I do so I'm going to do this again, and instead I'm going to just get the raw content, so that I'll just use this here. Okay, I'm gonna print that and call it on. Right. So I'm gonna remove it from the either. Okay. Do we see JSON in there? I guess I can test this by saying scrape the string JSON. All right, you know what? I'll be a little bit more specific, and I'll look for that source. Convert it to. Keep doing that. Just JSON. Okay, so there's JSON in there. So let's try this again. Cool. So we can see we've got JSON in there, and this worked. So if I could in theory create a JSON object here, or I could parse this as JSON, and I could do the work of creating a specific type like DeepSeek response, and then I could parse out that JSON from this, and so like. Yeah. Also, I'll definitely say that like it might seem like I'm a little bit all over the place with this lesson. Definitely am. I'll admit that. But I definitely think that this is like a key skill with like using AI. Obviously, we haven't built an AI here, but I think like AI as a full stack engineer is interesting because um, you know AI is all over the place, right? Like if we do the same thing, if we're to use ChatGPT for example, it's like one response is like this is great. Another response is like I've literally seen ChatGPT say I'm sorry, but your request is offensive, and I'm just like asking for it like in JSON. Like I have no idea why it failed, um, and I'll literally like retry. Like I'll like there's even like a Haskell library which does a very similar thing to what we've done here today, and I see that it has like built in like a retry option. Like how many times should it retry? Um, and that's because like it's just AI is random and AI is not very type safe. Um, and so we need a way to deal with that. Um, so that we can build these type safe applications, but also use AI where we should, right? Um, and again, another example of where we use this is with like with checking that people's names are correct. I wonder. The auth onboarding. Oh, submit onboarding. Leave this down here. Yeah, so like we use this ask ChatGPT typed um, to get the username and see if it's offensive or not. And so like I actually had to stop using this because it was like it was well we still use it, like it still flags if I if it sees a name that is offensive, um, but instead of like failing on the request, it will just tell me about it. So like I probably shouldn't show that piece, but if and so like ultimately what we'll see up in the code is that like it checks this, and then it just sends me an email if it thinks it's offensive. um, and before, what I was doing is I would have like this is the example that I'm trying to avoid here, right? Is I would say like if offensive, then like like request error, um, like you cannot do that, you can't choose that name or whatever, and we would get that for like you know um, any name. Actually, what we had before was if the request error case happened, then just pick the name for them. And so the name of the request, or sorry, the name that you would get instead, like you would say like my username is Galen, and it would give you back elaborate orator. And we had at one point in time, we actually had like 100 people sign up like around that time, and so we had like 100 people named elaborate orator 1, 2, 3, 7, 8, 9 or something like that. So you know AI and type safe programming are is a very interesting intersection is what I'm trying to get across. Um, and so that's why I have something like this sort of ask GPT typed, which ultimately just uses some like advanced Haskell to see like did we get back the type that we want. um, and we also I do some other cool stuff here, like I've used advanced Haskell to say like I'll change the prompt based on the the what we want back. So like if I say that I want back an integer, then this where does it do it? Yeah, this value here is actually going to be a text saying please only respond with nothing but the Haskell type int, or map of int to int, and it will just figure out how to do that on its own. But yeah, I think that's pretty comprehensive. I wanted to get a little bit further